Welcome to today's session on simple linear regression. Okay, so regression is a continuation of correlation. Suppose if you have two variables x and y, say suppose income and expenses, if they are correlated, if they have some relationship, then you can find one value given the value of another. Okay, so this is called as linear regression, simple linear regression. Let us see one example for that. Say suppose we have two values x and y. X is nothing but the expenses and y is nothing but the income. Okay, say 1 2 3 4 5 6 7 8 9 10. So there are 10 expenses data and 10 income data in y. Expense data is stored in x and income data is stored in y, and we build a model using this x and y using the function LM. So this LM function stands for linear regression, simple linear regression. LM function is used. Okay, so we are building the model for y against x. Okay, so the model is built using the LM function and it is stored in the variable model. Okay, suppose if I list the variable model, it will show you the model value. So simple linear regression can be expressed in the form of an equation y equal to ax plus b. Okay, so the value of a is 6.746 and the value of b is minus 3845.509 in this case of model. So that is what we can understand from the values of the model listed. Okay, suppose if I am listing the summary of the model, it will show you different values, the min value, max value, first quartile value, median value, third quartile value, etc., and the expected error value and the p value will be listed. So the p value here is 1.164 e to the power of minus 0.6. Okay, so that is we are going to have very minimal level of error in this case of simple linear regression. Okay, so now we have built the model using the x and y values. So we have trained the data with the given 10 values, and we are going to give a new value of x, that is a new expense is going to be given, and that is stored in expense. It is converted into a data frame and it is stored in the variable expense. Okay, so if I am going to predict using the model and using this expense variable, it is going to give me the new income. So that is for the expense 4700, what is the income I am going to predict using the model of simple linear regression. So for that the predict function is used. Okay, so now income has the value of the income predicted for the given expense 4700. So the expense and the income expected is 27,861. Okay, so that is the income expected. Okay, the same thing can be plotted in a scatter plot using y and x. The color is given as blue and the topic for the graph is given as income and expenditure regression, and the regression line is mentioned by using the function abline and using the model lmx tilde y. Okay, and CEX stands for the font size and PCH stands for the shape of the plot, and X label is income in rupees, Y label is expenditure in rupees. So let us run this plot. See here, you can get a plot, you can zoom and see the plot. So it is income and expenditure regression line. So the regression line is this straight line. So the abline function draws this line, straight line, which fits to the different scattered points. Okay, so these blue points are the plotting for the different income and expenditures given in x and y. So and the model is given by this straight line which is fitting all the data points, which is nearing to all the data points. Okay, so this is how we can visualize the regression. Okay, so we have seen one example. Another example, let's see, using the weight and size of mouse. So there are 10 weight and 10 sizes of a mouse, and it is stored in a data frame, and it is stored in mouse.data variable. So let me print the mouse.data variable. You have different weights, some 9 weights and 9 sizes of the mouse data. So I'm going to plot this mouse data weight versus the size in a scatter plot. So this is not a regression plot, this is a simple scatter plot. So which shows there is a positive correlation because it starts from the left hand side lower corner to right hand side upper corner. The points are scattered like that. Okay, so now let me build the model using the LM function for the weight and size of the mouse data. Okay, and I'm storing that in mouse.regression. So I have mouse.regression, which is the model built for the mouse data, and the summary for the same is listed here, and the app line will draw the regression line in the scatter plot. So now if you see the scatter plot, so this blue line is the regression line which fits the data for the different weights and sizes of the mouses. So now we have seen two examples for simple linear regression, one for expense versus income, and another one is for the weight and size of the mouse data. Okay, so it is clear now. We can use the function LM to build the model for regression, simple linear regression. We can see the result of the model using summary function, and we can use the predict function to predict the value for a given x value. What is the y value, we can predict that, and we can use a scatter plot to print the different data values, and abline function is used to draw the regression line taking the LM model. Similarly, it is drawn for both the examples. Hope it is clear. Thanks for your patience listening.